Good morning, beautiful people, and welcome to Space News, Day 16. My name's Mike, and I am adjusting my microphone. Give me a second. That didn't work. Come on. Let's try the audio like that. Gotta move my pop filter. That definitely didn't work. It's kind of annoying. There's a lot of tension on my microphone cord, so it tends to pull it downwards when I don't want it to. All right, let's try that. Let me go back. I'm going to do a quick loop of the stream, make sure that my audio sounds good, and then we'll get right to it. Thank you for your patience. Let's try the audio like that. It's kind of annoying. There's a lot of tension on my microphone cord, so it tends to pull it downwards. Let's try the audio like that. It's kind of annoying. There's a lot of tension on my microphone cord. Hello. Do you know what the other solution was? Relieve the tension on my microphone cord. Not very smart. Okay, let's get into it. My name is Mike. We are going to discuss some space news. I have opened up Ars Technica, spacenews.com, as well as Payload Space. I want to try something new. What we'll do is go through all three websites, do a quick browse, and if you in the comments want to let me know what you want to talk about, we'll open up those specific news articles. Otherwise, I'll just pick whatever kind of pops out to me. So without further ado, if I have a look at Ars Technica, unfortunately there have been no new posts. It's February 8th. I do see just a daily telescope, so maybe no Ars Technica for today. On Space News, we have a couple articles, one on the Falcon 9 launch with the PACE Earth Science mission, so that's definitely going to be something we review. There is an article on Black Sky inking a $50 million deal. This is for imagery services and satellites to Indonesia. And small launch companies seek niches to compete with SpaceX rideshare. It'll be interesting to understand the differences in technology that they will go for in order to make themselves competitive in a certain niche. So let's definitely look at that. Japan funding water-based satellite propulsion. I believe there is a space tug company that's also already doing this. I forget the name of that tug though. Tech executive Tim Som's name, Slingshot. Okay. Also, one thing I want to look at, you remember that company in the US that was firing satellites into space by spinning them really fast? I'd love to look into that. What was that called? Launching satellites into orbit via what's that? Centripetal force? I don't know how to spell it. I'm going to embarrass myself. Centripetal. Oh, centripetal force is entirely the wrong. It's entirely the wrong term. So they want to throw satellites into orbit with a giant centrifuge. There it is, and it's called SpinLaunch. I also want to look into SpinLaunch today. So currently on the docket, we have one article on the Falcon 9, one on small launch companies seeking to compete with SpaceX, one on this water-based satellite propulsion upgrade. We're going to look into SpinLaunch, and if there's anything on payloadspace.com, we can have a look at that as well. Starship is misunderstood, so there's a report on the Starship. We could probably look at that tomorrow. And Black Sky wins $50 million projects. That's on both websites, eh? Yeah, so one here, February 8th, Sandra Irwin, and then one here, February 8th. I assume it's different. Yeah, Jacqueline Felcher. Okay. Sounds good. Nothing here. This is more business related, so let's close these out. We will start with the Falcon 9 launches Pace Earth Science missions. Here's a beautiful picture of the Falcon 9. First stage, I actually don't know the breakdown of the Falcon 9. Let's open that up. So it's a two-stage rocket. The first stage, also known as the booster stage, carries the second stage and payload to a predetermined speed and altitude. Can we get an image breakdown? I think that would be more helpful for people. So here's the Falcon 9, here's the Falcon Heavy. The first stage has 9 engines. Wow. And up here, I assume this is a fuel tank. The second stage is all the way at the top, so it's maybe the last quarter of the vehicle, and that has 1 engine and something like a payload fairing, which is essentially, I mean, if you've ever played Kerbal Space Program, you'll know it. You have a disk that you can build sheet metal, kind of, you use that as the base for a bunch of, not sheet metal, definitely not sheet metal. You use that as a base for some metal that will go around whatever your scientific payload may be. And it gives you that it protects the payload and gives you that aerodynamic shape that you want when launching rockets. On the left here, there's the Dragon capsule, which would contain the actual astronauts. Very cool. Let's go back here. So first stage, second stage cutoff looks to the decoupler looks to be around here. They have a, so I've always wondered what these external towers are and why. So there are cables that go between these 4 towers. Are those cables used for stabilization? I'm not sure. If you know, leave it down in the chat. Let's get going. So the Falcon 9 placed a NASA Earth Science satellite into orbit on February 8th. Let's just take a moment. Every time this rocket goes up, something works. Something goes into orbit. That is an absolutely amazing feat. These people are launching like a rocket every 3 days. At least last year, 98 launches. They have a 99% success rate. It's absurd. That was the first of its kind for the US government in more than 60 years. The Falcon 9 lifted off from Cape Canaveral at 1:33 a.m. Eastern after 2 days of delays caused by high winds. Delays by weather for launches, very common, very annoying. There's a running joke in a lot of aerospace companies that when you have a launch scheduled for, let's say, March 1st, you just say it's scheduled for May 1st. It almost never launches the day that's actually scheduled. It's placed into, and I think SpaceX is working on improving its technology to be able to launch in more let's call them extreme weather conditions. I'm not sure what the go no go signal is, but to someone who is very ignorant, it almost seems like if someone is breathing too hard, they cancel a launch. That's, again, I'm very ignorant about this. So it was placed into Sun Synchronous orbit. This is the NASA's Plankton Aerosol Cloud Ocean Ecosystem spacecraft, or PACE. PACE carries instruments to study both ocean color and as a means to monitor biological activity like phytoplankton, as well as clouds and aerosols in the atmosphere. It was developed by the Spaceflight Center in Maryland called Goddard, and it cost about $1 billion. NASA satellites are very expensive. Commercial satellites go for 10, 20 million, depending on what you're building. $1 billion is absurd. So in many ways, we know more about the surface of the moon than we do our own oceans. So that's a cool take. So PACE will be the most advanced mission that we've ever launched to study ocean biology. Okay, let's see if there's anything else. So it's sun-synchronous orbit. The reason you launch in sun-synchronous orbit is that you're able to look at places on the Earth at the same kind of luminosity that the same luminosity day to day. And that's because when you're flying over the poles, the Earth is spinning underneath you, and you have selected a launch that allows you to kind of come up or ascend over a certain location when the sun is hitting that location at relatively the same amount of energy. So you will be able to image, a certain latitudes with really good sun coverage, and that's obviously very useful for any craft that's performing Earth observation. I've said all of that. That's my understanding of sun-synchronous orbit. Let's have a look at what the real answer is. Sun-synchronous orbit. So for those of you that kind of have come in late, the whole point of me doing this really is so that I can learn more about, my career, learn more about aerospace. And so I will say things that, I usually like to make a guess first, and I try to be as obvious as possible that is in fact a guess and not factual, and then I go about trying to correct myself if I can. So that's the main reason that I'm doing this is so that I can continue to learn about my own profession, and this kind of secondary goals are to get comfortable in front of a camera and to build out an audience, maybe build out a second source of revenue. And yeah, it's a fun thing to do. I really like doing it. So a sun-synchronous orbit, also called a heliosynchronous orbit, is a nearly polar orbit around the planet in which a satellite passes over any given point of the planet's surface at the same local mean solar time. So mean solar time is the hour angle of the mean sun plus 12 hours, okay? So the duration of daylight varies during the year, but the length of a mean solar day is nearly constant, unlike that of an apparent solar day. So currently, my understanding is that me living in someplace on Earth during the summertime, I experience more sun than I do during the winter periods. But it seems like the goal of sun-synchronous orbit is to give the satellite kind of they don't experience summers and winters. They always get the same amount of sunlight all the time. Let's continue looking into this. So the satellite passes over any given point on the planet's surface at the same local mean solar time. More technically, it is an orbit arranged so that it precesses through one complete revolution each year, so that it always maintains the same relationship with the sun. Orientation of a sun-synchronous orbit at 4 points. Okay, so let's have a look at this photo. Maybe this will help us out. So it's 2103, 2212, 2309, 2106. So this is like 2021 March. This is 2021 June. This is 2020. I'm confused. No. So 3, 6, 9, 12. Those, I get the impression those are the months. The numbers on the left, I don't think those are the years. That wouldn't make a lot of sense. So I'm going to assume that those are the days. So let's just look at the months here. So starting in December, we have the green circle and the pink circle. So green is the orientation of a sun-synchronous orbit at 4 points in the year. So the sun-synchronous orbit, go back, in December is at a certain point, and a non-sun synchronous orbit is also shown for reference. Okay, that'll be very helpful. So the green line, we have a point here with respect to the sun and a point here with respect to the sun. This would be somewhat in eclipse or fully in eclipse, whereas here the sun is providing energy to it is illuminating the surface in this area, and so an Earth observation craft here would be able to pick that up. Now let's move forward to the 3 months ahead. Now we're in March. We have a craft here which again has the same illumination. It's kind of the same illumination pattern as we had here. So whatever this point is, it's illuminated, whether it be in December, whether it be in March, we are receiving the same amount of sunlight. Whether that's the same spot on Earth, I'm not sure. Let's have a look at this pink line. So we have a spot here. So if we look at the angle between the sun and the pink line, you can just follow the plane here. That's almost 90 degrees, whereas between the sun and the pink line here, that's almost parallel. So the orbit has changed for whatever craft is in it. Whereas at the green line, the orbit is constant, no matter where the Earth is at around the sun at that time. Okay, and this green line here, why are they offering? I'm not quite sure why they're offering this dotted line. So the delta sun synchronous orbit is equal to the change in Earth, which is 360 degrees a year. So the orbit itself appears to be rotating 360 degrees alongside the Earth. Someone surely will explain this pretty well on YouTube. Sun synchronous orbit. This may just turn into a lesson for both you and I on sun synchronous orbit. Any audio? No. So we watch the Earth as it rotates around the sun. The red line dictating the Earth observation's orbit shows that
The definition of a sun-synchronous orbit is a near-polar orbit whose nodal precession rate is equal to Earth's mean orbital rate around the sun. Now watch what happens when we speed up the time here in the simulation. The orbital plane here is precessing due to the...
Okay, so the orbital plane, when they say the orbital plane is precessing, that if it does not precess, that means that the satellite is always flying. Wow, this is very tough. It means the satellite is always flying. Like if you have, it seems like you're pinching the north and south pole, let's say, so that those 2 points don't change. But the way with which the satellite precesses or kind of orbits over those poles, the angle between, let's say, some normal and where the satellite is actually orbiting will start from 0 and will change, and eventually it becomes 360 degrees, and it does so in such a way that it is in line with the Earth's rotation around the sun. Okay. So let's get back to why we were talking about this in the first place. Because PACE was launched in a sun-synchronous orbit. So PACE will go back here. So PACE is kind of is guaranteed to always receive a certain amount of sun, no matter what time of year it is. Okay, that seems important. Let's check out the alternative, which is this magenta line. Here it's receiving some amount of sun, let's say. Here it's receiving a lot of sun on this side of the orbit. Here it's receiving some amount of sun again. And here it's receiving a lot of sun. So I'm guessing in terms of the technology, it's probably, you want to be as consistent as possible with the amount of exposure you are getting from the sun. Really dived into this. I really dove into this. When you're recording yourself live, you definitely have the ability to make yourself look quite ignorant. Let's carry on. I think this is something that I'll let it sit in, and then maybe tomorrow we'll go through Synchronous orbit again. I will retry explaining it, and ideally I'll make small improvements until I get to the point where I can really concretely and simply explain to you, lovely viewer, how Synchronous orbit works. Also, we're at what time now? So we've been streaming for 23 minutes. I normally try to keep these shows to about 15 minutes, so we might not get to these other articles today. I mean, what I might do is just call this video Mike Destroys Explanation. I mean, destroys is usually used as a good term on YouTube, so Mike looks like moron on camera. There you go. So SpaceX won permission from the Eastern Range to carry out Falcon 9 launches on southern trajectories to access polar orbits. Credited SpaceX's use of autonomous flight systems and the ability of the first stage to land on a drone ship or back to make launches to polar orbits feasible there. Okay, so this is cool. What's happening here? So this was the first U.S. government mission to launch to a polar or sun-synchronous orbit from Florida, so this is Cape, since 1960. There were several such launches from the Cape in early years of the space age, but those stopped after a November 1960 launch failure dropped debris on Cuba. Not good. And that's nice of the U.S. not dropping commercial or government property onto a foreign country. Not foreign, yes, but sovereign's the nicer term. SpaceX won permission, and essentially because the Falcon 9 is so robust, you could fly that over my house, I wouldn't be that concerned. Credited SpaceX's use of autonomous flight systems, Okay, cool. So it carried out 11 Falcon 9 launches to polar orbits from Cape before pace for other customers. So the government was really saying, we just don't want to be responsible if you do dump a bunch of vehicle parts on Cuba. There is no question that this is a well-exercised process that we're doing. Therefore, if we piss off our friendly neighbor to the south, it's not our fault, it's Elon's. Most polar launches still take place from Vandenberg. Okay. The spacecraft team, being from Goddard, preferred to launch closer to their center. Florida is much closer to Goddard than California. Let's have a look at that. So Goddard, Maryland. I genuinely have no idea where this is on the map. As you can imagine, Maryland is not the first state you think of. Why would I go to images? There's literally a maps option. So Goddard Space Flight Center. Go away. Oh, Washington. Okay, well, yeah, definitely closer to our friends down in Florida than it is way over here in California. Okay. Gone. All right, so we're going to move on from the PACE Earth Science launch. We are now going to talk about how small launch companies seek niches to compete with SpaceX rideshare. Here's another view. Oh, this is a view of the Rocket Lab Electron rocket. They had 8 launches in 23. They launched 4 North Star Earth. I believe that's a Canadian company. Go us. Yeah, it's based in Montreal. So it's their satellites are doing what? I feel like So they're delivering commercial space-based situational awareness services to enhance sustainability and security. Okay. What exactly is your technology doing? So it's part of a movement towards space safety, sustainability, and security, radically changing humanity's interaction with a fragile space environment. Okay, what is your mission actually doing? So they declare that they will support, sustainable and clean space environments. So North Star's precise information services identify and anticipate the position of space objects to enhance spaceflight safety. So space objects, whether it be, I don't know, Canadian satellites, American satellites, other countries' satellites, I imagine that's in the mix. And so this company probably has some military contracts, but they will also be detecting probably things such as asteroids, foreign, any sort of rock in space that perhaps could be of interest to us, whether it's coming towards us or it's flying away from us, but may have some precious metals. It's not very clear what exactly they're trying to do. So North Star addresses the ever-growing threat of space collisions as a major contribution to empower humanity to preserve our planet. Okay, so it mostly just seems like they are focusing on the potential of collisions between satellites and other space vehicles, and it looks like Spire's involved somehow. This is a satellite manufacturer. So their partners in this endeavor were Rocket Lab, Spire, and SpinLaunch. Cool. Okay. Let's get out of there. So small launch vehicle developers are working out to carve niches in a market for small sat launches that are increasingly dominated by SpaceX's transporter rideshare missions. So currently, Falcon 9 can lift more than 100 small sats to orbit wherever they want to go per flight. Whereas, what are these other? So the transporter program was created a few years ago with the sole purpose of trying to kill new entrants like us. Talking about Rocket Lab here. I mean, I think the goal of these transporter programs, is to get the Starlink satellites into orbit. Musk, not just Musk, but SpaceX has launched over 5,000 Starlink satellites. So that's definitely a high priority for them, and makes this statement by the director of global commercial launch services at Rocket Lab, seem quite silly. The uniqueness, he argued, is the ability to fly missions to specific orbits not served by transporter rideshare. Like what? I'm curious. So an example is the next Electron launch, which will place into orbit the ADRAS-J Inspector satellite for astroscale. That mission requires a specific precise orbit so that ADRAS-J can rendezvous with a derelict Japanese upper stage. Okay. So it seems like the the difficulty and what makes this niche is that the specific launch time will be determined just a day before launch with a near instantaneous launch window. So the trajectory of the vehicle seems to be very important. I think we should keep this and keep it in mind that this is coming from Rocket Lab. So they have it's very important to them, especially financially, that they separate themselves from the competition. So far, I'm getting more kind of hit piece and promotional vibes from this than actual scientific information. So most of the missions that they fly are enabled by the fact that we offer dedicated services. Other panelists say they are targeting customers with specific requirements or needs that make them less price sensitive than those who opt for the less expensive transporter options. So some of these launch companies like this Spanish PLD Space are offering premium services for the ones who are willing to pay. What are these services? Explain yourself. Right. And so if this sounds great, but one thing that we have to keep in mind is that to get into a certain orbit, it's not just about the launch vehicle, but there are also space tugs available that will help you transfer orbits. So maybe SpaceX gets you into sun synchronous 430 kilometers above Earth, and you need to be in 450. Well, you could have a space tug pull you there. So you have essentially the space tug vehicle, or what they're calling orbital transfer vehicles in this argument. This piece, you have your satellite connected to an orbital transfer vehicle. You launch that to 420, and then you have the orbital transfer vehicle move you the extra 20 kilometers or whatever up. So it has its own. We can call it almost like a third stage. So while that combination may still be less expensive than dedicated launches, it still doesn't offer sufficient flexibility, launch providers argued. So Exolaunch is a launch services company. So if it takes you multiple months on orbit to get to that final destination, there's a strong argument to be made to going dedicated. And that's fair. That's a really good point. If it costs you, if your satellite could be pulling in, let's be ridiculous here, $10 million in revenue every month it's up, then it makes sense to just launch to the right orbit. Yeah, it might cost you an extra $5 million, but you made $15 million net for the extra 2 months. So the maneuvers that require plane changes can take months to complete. And that current orbital transfer vehicle providers have yet to demonstrate the ability to perform such complex maneuvers. I guess the difference between space tug and orbital transfer vehicle is the orbital transfer vehicle is something that was planned ahead of time. So you have your payload on the OTV, and that will get you to the orbit you want. Whereas space tugs probably are more of a rescue style mission, maybe or an extension of life mission. So, we have satellite A, it's performing really well, we want to keep it, but over time satellites do descend, their altitude will drop, and so can you get your space tug to come in and pull us up a little bit? We'll pay you, I don't know, $1 million, but again, if that makes you that gives you an extra 2 months and you make $10 million a month, you can see the finances really work out here. If you are a small sat company, your business model should be looking forward to the model of the Starship rideshare. This is coming from SpaceX officials, I assume. I mean, yeah, Falcon 9's crushing the competition. Imagine what Starship's going to do. You can throw mass and power and volume at your problem and thereby scale up your satellite bus and still be cheap. Yeah, it's unfortunate. I think some missions have difficulty because sometimes this can be these extra engineering constraints can be a good thing. Some of them can be a bad thing. For it being a good thing, there was a very heavy weight constraint on the Ingenuity helicopter that was flying around Mars. And so instead of using a radiation hardened computer, they used a Qualcomm Snapdragon. And that Snapdragon performed perfectly for 72 helicopter sorties on Mars. So that's a great outcome, honestly, that makes commercial grade electronics much more viable now that it is shown and been proven to operate. That they operate in space, but also mass, weight issues can cause problems. Sometimes you can't include all of the electronics you want. Maybe your bus, I don't know, if you can only include 2 reaction wheels instead of 3, let's say, well, then your satellite can only turn a certain way, and you need to use more complicated drag maneuvers to try and orient your spacecraft exactly where you want it to be. That would be, I hope that that's never happened, but I could be wrong. I mean, there are also many ways to orient a spacecraft to change your attitude. I guess the kind of normal way to do it, especially with CubeSats, is to have reaction wheels spin very fast and kind of give you this really precise turning maneuver in 3 degrees of freedom. Yeah, 3 degrees of freedom. All right, so that is the small launch companies seek niches to compete with SpaceX rideshare article. We have I'm going to skip this water-based satellite propulsion upgrade article and move right on to SpinLaunch because it interests me more. So it's working on mass accelerator technology to move payloads to space. It received $150 US in September 22, so about a year and a bit ago. And they have some pretty serious, supporters: Google, Airbus. Now, where are they right now? So in 21, they conducted the first vertical tests of their accelerator at 20% of its full power. It hurled a 10-foot long projectile to an altitude of tens of thousands of feet. That's okay. Let's be generous and say 20,000 feet, 2 meters. So space, I think the orbital line is considered around 100 kilometers. We can be generous and say 70 kilometers, and they got to 6 kilometers. 2021, first launch. No, let's not throw smoke. The test accelerator is 108 feet in diameter, so 33 meters in diameter. The company's first 10 test flights reached as much as 9 kilometers in altitude. Okay, so they need a 10x improvement in order to, even consider getting into orbit. Something else that we have to consider: you can't throw the satellite straight up. It will come straight down. You need to throw the satellite with enough horizontal velocity such that it misses Earth, essentially, and when it's on its way down. So it will hit its apoapsis, and then on its way down from that point, it needs to miss Earth, and that's what we consider an orbit. So, I mean, they can't throw I don't think they can just throw, 90,000 meters. They need to throw much farther. I could be wrong. Let's see if they can give us more information on their website. Look at that. I love how I'm sure they can change the trajectory, the angle. Maybe, I don't know. Can they change the trajectory of their facility? I love that picture. It's beautiful. So their website is still referencing 2021. It looks like they are trying to solve 2 things. One, they're trying to solve how to get satellites into space, and 2, they are trying to develop the satellites themselves, because you can't just launch a traditional satellite this way. I think it experiences too much G-force while it's building up, while it's accelerating within the centrifuge. 12U microsatellite bus. Very cool. So yeah, I think a lot of focus with a 12U. You may have difficulty with Earth observation. I don't think you'd be able to fit a. I mean, here they show that you can have a camera with a, but you couldn't fit a baffle, which is typically used to eliminate or reduce stray light, which is quite important. Maybe this camera. I mean, this camera in this photo clearly doesn't need one. Or you could have a baffle that protrudes into the cube itself. So SpinLaunch can help to choose additional needed flight hardware such as OBC propulsion and communication. Okay. They have a 200 kilogram satellite bus. This is more than I thought. But what have they launched so far? Well, they have all of the different, they have a bunch of different devices. I wonder what kind of rating considerations would need to be made. When you launch something to space, you want to make some radiation rating considerations. You want to understand that that device will live for well over the desired lifetime of your craft. But these kinds of devices will experience a lot of centripetal force, a lot of acceleration. Let's go with that. And so I wonder what kind of rating considerations need to be made. Let's call it there. I want to thank you so much for sticking around and putting up with my learning exercises. I will come back to y'all tomorrow with more information on Sun Synchronous orbit. That's my pinky promise to you. Otherwise, have a lovely day, and we will chat soon. Bye-bye.